So good afternoon, all members and non-members. Welcome to the 7th HKIBIM CBD event. So I'm 𝗥𝗲𝗽𝗹, Chairman of HKIBIM for this term. I'll do a quick 5-minute run through of HKIBIM introductions, and then we'll hand over to the speaker for today. So HKIBIM is established in January 2009. So today we have more than 1,400 members. The object is to promote and advance the general education understanding and interest of BIMs, foster general awareness, establish and advance standards of BIM management within the industries, establish links with the government bureaus, statutory bodies, organizations, and tertiary educational institutes, to research and facilitate for the means of better BIM management, provide guidance on careers to the BIM management professions. So for these new terms, this is our work of for HKIBIMs. We have recently also announced the new community setup of public services. This is our corporate memberships. We welcome the new corporate members of 𝗥𝗲𝗽𝗆. China divisions was set up in Lastons. Today we have more than 30 members in these divisions. Young memberships. So this is a collaborations with the secondary schools. So we're promoting BIMs to the young memberships. CBD. This is the 7th CBD for these terms. So since the formation of the new board in April 2005, today we have run through already 7 CBDs. So hopefully we'll be able to meet the target of 1 CBD per month. Past events. So the last event that we have was Automation Arena 2023. And last year we have 2 site visits. 1 visit to the CIC Center of Future Constructions.
Screen is not moving. This is not.
Yeah. And the other site visit is Trunk Road T2. Just new announcements that we have signed an MOU with Korean Institutes of BIM together with HKIBIMs. So this was held in Seoul, Korea last year, 2025, on 14 November. So I was at the conference and we have signed the MOU. So hopefully we'll be arranging more and for some more collaborations with other international BIM institutes. Our HKIBIM social medias. So WeChat, Facebook, Instagram, LinkedIn. So please join us and stay tuned to our events. Upcoming is the HKIBIM Awards 2025. So we are targeting April this year for the award ceremony and dinner. So currently we are looking for sponsorships. So for this term, we have these are all the supporting organizations that we have invited. So we're looking for more sponsorships packages. So scan the QR code if you are interested. Please drop us an email. Upcoming more technical and automation sharing. So we'll let everyone know when the GitHub is ready. Okay, so thank you. Let me introduce the speaker for today. Today the speakers we had is Mr. 𝗪𝗲𝗯𝗶 Sim. So he's currently with Airport Authority Hong Kong as a senior project engineer. So without any further delay, I'll just pass it on to Jay. So Jay, all yours.
Okay, thank you for the introduction. I have spent actually nearly 18 years in the construction work as a BIM consultant, a modeler, discipline coordinator, and a project manager. Also worked for the design manager as a contractor. And I have also worked on technical sales. So I've seen construction from pretty much every angle. But today, I'm not going to talk about BIM as a technical tool. I'm here to talk about something bigger. I'm here to talk about transforming what construction is as a career and why that transformation is happening right now in Hong Kong. The title for this session is Transforming Construction Through Workers' Empowerment and Youth Engagement. And I want to start with a question that might simply cut the heart what we face. How many of you encourage a bright, ambitious 18 years old pursue a career in construction? Well, most of you will hesitate, and that hesitation, that instinct to steer talented young people away from construction. And more importantly, it's the core problem that Hong Kong is now solving. So here's what we're going to cover today. We're going to understand the demographic crisis. We'll see what young people currently think about construction. We'll discover what Hong Kong government is already doing over 25 coordinated initiatives across 9 organizations. Then we'll understand how Tier 4 BIM, which is what I'm trying to propose today, comes to a bridge between crisis and the solution. We'll walk through career path transformation, and finally, we'll look at the competitive advantage window that Hong Kong has right now. Today's story is about transformation, and it starts with understanding young people of why avoiding construction. So to share a little bit of my own journey, because I shaped it and how I see it, I worked on my way through major projects as a BIM consultant, starting from modeler, discipline coordinator, managing conflicts between MEP system and structure. These are actually, been a project delivery, and I've been seeing all these kind of technical issues all around, from construction sites to BIM implementation progresses. Throughout each of the roles that I have actually encountered, I learned something very fundamental. The decision-making of every person at whatever level directs impact to project quality and the cost. The project manager decision ripples through the teams. The foreman's decision impacts the crew, the workers' issues, and how may interpret it a specification, what they spank up about potential conflicts. That decision shapes project outcomes. But here's what I noticed across all the projects. The biggest impact doesn't come from top-down decisions. It comes from something very simpler. It comes from break down large, complex text into simpler parts that can be seen and glimpsed and manage them, so everyone understands their role. So everyone understands. And that's the core here. And this always begins with the one thing: respecting one another. Respecting that the worker on site has intelligence, the insights, respecting the engineer constraints, understanding the architect's design, what to provide the space understanding to the user. Respecting the project manager is juggling dozens of variables. Respect that insight that combines clarity, that drives excellence on projects. And that's exactly what I'm trying to promote here about Tier 4 BIM, combining with government initiative we're going to discuss actually later on. So today, message isn't about imposing technology or construction workers. It's about empowering them with information, respecting their ability to make good decisions. So here's my agenda. We're going to first look into the workforce reality, the demographic numbers that create urgently, not abstract statics, but concrete numbers about who is in our workforce right now and what happens in the next 5 years. Second, we'll examine perception and reality, what young people or non-AC people think construction is versus what actually is today. This gap is actually important because it's not a realistic problem. It's just a communication problem. Third, we're going to look at the actual what's happening now in Hong Kong with Hong Kong government plus AI initiative with HKIBIM's initiative. This is an exciting part because it's not theoretical. It's actually or more than 25 initiative, active deployment, real projects, real results happening last year and what's going to happen this year. Fourth, we're going to dive into BIM implementation tiers, which I'm trying to propose today. Most people think there's only one part of it, actually design phase coordination, which we're actually doing. But there's actually four. The last four is the point of work BIM, where there's revolution happens. It's also where Hong Kong has global advantage. Fifth, for the fifth part, we'll explore career pathways and pipeline strategies. How we transform construction into a career that ambitious, talented young people actively want to enter, not because we convince them, but because the work itself changed. And finally, for the conclusion, trying it all together to a core-hearted transformation story. Through the connecting everything, worker empowerment using information given frontline workers clarity, context, and the ability to make better decisions and use that to attract the next generation. So this is the message that I want to convert today. So workforce reality. Before we go into the data, I want to make it transparent about where it comes from. This presentation draws on multiple sources across 3 regions because understanding what workers elsewhere happens helps us understand what we should do here. From the United States, the Eye of Housing Analysis from the National Association of Home Builders and CPWR Construction Chart Book, these give us detailed age distribution data and generational patterns in the US construction workforce. From Hong Kong, official data from the Construction Industry Council, CIC, our industry's registration database, academic papers from City University, particularly researching on aging construction workforces and occupational health. In Hong Kong, Legislative Council reported on government manpower forecasting. From South Korea, official construction demographic data reported the Construction Engineering Policy Institute and coverage in the Korea Herald about government initiatives. From the UK and international comparison, academic research on construction apprenticeship, BIM effectiveness studies, and IOL global workforce statistics. The reason I'm emphasizing this is actually simple. The numbers I'm about to show you are actually real. They're verified across multiple sources with several AI tools that I used, and they printed a clear picture of the industry in transition. So when I show you numbers, you can be confident these aren't worst case scenarios or extrapolations. These are documented facts. So let's look at the chart from here. So this is actually Hong Kong's workforce table. Let's think about a moment. Not just older workers we're talking about, people who are likely already thinking about retirement within 5 to 10 years, which is 50 plus people. Compared to that, other industries like finance, it's 23%, or in 50 plus. Technology, it's 18%, and you can see the pattern. Construction is dramatically double older than any other major industries. The second column, only 5.9 of construction workers are under 25 years old. On the other hand, in finance, 14% of the workforce is under 25. In tech, it's 16%. Construction, we're very low, 5.9. The construction workers, the median level is 42.8 years old, which means in healthcare, it's 40.2 years old, finance is 38.5 years old, tech at 35.1 years. As you can see, construction has the oldest workforce for major Hong Kong industry by significant margin. And here's one that keeps government planners awake at night. 41% of today's construction workforce will retire at 2031, 5 years from now. Now, slow decline over the generation. We're talking about losing half of our senior expertise in the industry within a half a decade. To put that concrete number, Hong Kong needs approximately 400 to 800 new construction workers annually. That's what government research shows. But simultaneously, we're losing, 40 to 50% expert personnel. We're not just facing shortage, we're facing workforce collapse scenarios currently. And that's the urgency driven every day happening right now. So obvious question, why? And why are young people avoiding construction while they can enter finance, tech, healthcare, and engineering? But the answer isn't that young people lack ambition. The answer isn't that construction job doesn't exist. The answer is that young people don't see the construction, the reality of it. Here's the research shows. A first barrier is about the visibility, the invisibility. Construction is literally not on the radar. The students go through secondary school, maybe polytech, and nobody presents construction as a verbal career option. They know about investment banking. Parents talk about it. They know about law, TV show features about it. They know about tech. Everyone's on social media watching influencers. But construction, the only image that have is someone with a hard hat and muddy sight. That mental picture here. The second barrier is perception of workplace culture. 35% reports this concerns. About a third of young people who consider construction perceive it's having poor workplace culture. They see it physically demanding on point of chronic pain, disrespectful, and especially to women. 53% of women say that the industry isn't welcoming them, not interactually engaging as a dead-end part. The third barrier is limited career visibility. 50% of people who took the survey said that. Young people can picture investment banking as a career path analysis, associate, VP, managing director. They can picture technicians, engineer, tech lead, manager, director. But construction, they see it as just a labor or foreman. And then what? That's it, right? So there's no visible path to leadership, to innovation, to strategy. There's no picture of I can become a leader of construction in general people's thoughts. Now here's the critical insight. Perception is actually a choice, and if we change construction actually what it is currently, if we can make the technology enable and intellectually demanding and visible progress, we can bring in smart people and young people to follow. The question isn't how we convince young people to do old construction jobs. The real question is, what if construction, what we are actually doing, it's self-transformed into something they want to do? And the transformation has happened, and actually it's on the way. It's just not showing in the surface. So the perception and reality. When I say young people are rejecting construction, they're not actually rejecting the real construction. It's actually they're rejecting something they think about. The vision that doesn't exist anymore. The concepts are like back in the 1990s. Modern construction has completely transformed, But because construction doesn't market itself, because young people doesn't see it, what modern construction looks like today, they make their career decision based on outdated information. Let's think of it this way. Imagine if a young person only imagine engineering come from watching 1970s bridge building footage. They think engineering is about calculating and hard hat and pencils. They won't see modern engineering. The AI optimization in IoT sensors, the digital twin, they reject the professions based on phantom image. That's what's happening with construction at this moment. So the real opportunity is this is what we're going to explore today in this show. Young people, what construction actually is today, not yesterday. So let me show you this table, the 5 biggest perception reality gaps. As we go through each one, what happens, watch how outdated perception is compared to reality. Now, the first rule is about status. Most people who's actually not in the AC industry, construction is something you do it for. You can't if you can't do anything else. It's low class, blue collar work, low prestigious. But here's the reality: modern construction coordination is highly skilled work. We already know. You're managing dozens of moving pieces simultaneously. You're solving spatial problems. How does systems fit together when they're competing with others on the same place? You're making trade-offs between cost, schedules, and quantity. You're responsible for worker safety. You're responsible for project outcomes. A BIM coordinator and the construction manager is not manual labor. They're the problem solver. They're decision makers, and they have skilled professional works. And actually, the construction as a project is just a slower version of rocket science. Everything moves simultaneously together, and it matches piece by piece, and it operates. So that's the status of misunderstanding. The second rule is about technology. Ask an 18-year-old what construction is at the picture of a pick of shovel, manual labor, hard work, physical work, no technology. But we're, that's way back in the 1990s. But walk onto a modern construction site in 2026. Well, we do present this a lot in our own awards, but it doesn't go out. So you'll see workers' tablets, we see 3D models, we see drones, we see laser scanning point clouds, we see all these automated point clouds and automated spreadsheets generating, augmented everywhere. So, and this is actually what was happening on what we actually show to our career paths. And stuff, and then intelligence. Modern workers actually think about more how to make better decisions rather than just rely on papers and drawings. They look into 3D models and compare what's the best solutions to build the area. And these intelligence are critical to modern construction worlds. What you choose and what you prioritize actually controls what it actually happens. And a lot of people think that AI will actually overrun, construction jobs, but actually it's not. It will actually help you to take a higher value jobs like robot operators, AI spatial analysis. Jobs don't disappear. They provide more high wage, lower fiscal demands. So these are the actual things that actually happen, but it's not actually going out from our AEC industry. So these are actually has to be showing out from what we are doing. So these are the actual perceptions. Now, but there is a problem. The theory of the change that drives everything we're about to discuss. So from the left side, you can see the gap we identified. 5 precious reality dimensions. Young people see one thing, reality completely different, which we're doing. This gap exists because construction work, especially work level works, is invisible to young people. You know, you don't go see every time on site what the workers actually do. And it's natural. They don't see it. They don't understand. So there's perceptions default to stereotype. In the middle, here's how the gap gets close. You know, tier 4, what I'm trying to propose is a worker level BIM. Instead of BIM existing only for architects, engineers, and a BIM at their desks, if you bring the BIM model to the worker on a tablet or in the field in real time, the worker can see exactly component what to do in 3D visualization. And then they will understand the tone specification, the extract, the visuality. What happens before and after when you do the work? Any conflicts, other trades, will bring actually early warnings. These are revolutionary because the worker stops operating on basis of guesswork, which is paper, and vague verbal instructions. They're operating on basis of compliant information. If you give the whole BIM model to the workers, they'll exactly know what to do. This is what I actually experienced without in my projects, and it really helps them to provide new ideas of looking into the project and what to solve first before you go to the next project, because there are skilled workers on site. They lived on it. They have all the know-how. But if you give them these kind of technology, you will have new information from them. So, and young people who sees this version of construction work, not an outdated manual labor, but informed decision-making critical work, young people respond to that. I mean, I will respond to it because I was very surprised to this. That's the visibility mechanism, and that's the missing link here. On the right side, here's what happens when you introduce when I'm trying to introduce tier 4 into youth recruitment and educational pipeline. Young people see the modern construction site and think, that's not my grandfather's construction job. It's not going to be your grandfather's construction, because you see the whole construction before it happens, and you know what's going to happen to it when you look into the BIM model and where specifically where it has to be. They see it's if you give them these tech, they will see the tolerance specification, decision makings, and that itself is intelligent. They see clear career progression. Most people, if you have this kind of showing to outside of the AC industry. So more importantly, you can build a career on top of it. When they use BIM as a vocational training or university, when they experience the intelligence and change and feels the problem-solving aspect, they understand instantly that this skill works. And HKIBIM actually proven that on the 15th anniversary. There were secondary school students who actually presented their BIM model and how they wanted to do with it in early stage. And there's perception shift. Everything perception gaps gets addressed, not through talking about it, but through showing, through experiencing it. So these are very important factors that what we can actually do. And so before we move on to what actually Hong Kong government and BIM and AI initiative do, I want to show that what other countries have already done because understanding their path helps us understand ours and where we can lift up ahead. This is a simplified table from 2025. Snapshot of a few regions have structured their own BIM mandates and roughly adopted the status. And it's a rough status from it. So United Kingdom, 2016, they have actually adopted a BIM level 2 for all public sectors, over £5 million. That was 9 years ago. Today, they adopt around 70%. That sounds good, deeper adoption at almost entry at design and management levels, but there's no adoptions to the worker level. So they solved the design problem. They didn't have solved execution. Architects, engineers uses BIM, coordinators uses BIM, but what about the frontline workers that actually work on site? Still operate largely on guesswork, on words. Singapore, 2011, introduced Cornex, a mandatory electrical submission system. They've been there for 15 years. Currently, adoption is around 80%, the highest in globally. But again, it's primarily at design and management level. They're more advanced than UK in overall adoption, but they still haven't cracked the point of work BIM integration. That means labor level of BIM integration. Why the gap? Both countries are sophisticated construction markets, but have mandates. Both have invested heavily, yet worker level point of work BIM, where frontline workers access simplified information on tablets, remains under less than 5%. The barrier isn't technology. By 2011, tablet existed, 2016, cloud computing, and we put everything in cloud these days. It was reliable. And now by 2025, internet is like a ubiquitous. The barrier was organizational, not technical. Les knows how to actually simplify BIM for workers. Education system hasn't adopted, industry standard didn't support it. So, and again, Hong Kong, 2025, Development Bureau, Technical Circular, January 2025, mandates BIM for public capital works projects over 30 million Hong Kong dollars. This is our moment. We have around 2 years window of the opportunity to do what UK and Singapore hasn't done yet. Implement work level BIM first at scale across industries. What if we'll follow the path about design stage adoption, which we're currently only doing? We'll be rich in design BIM, but very poor in executing the works. If we move now, we can establish Hong Kong as a global leader in execution, where workers are empowered through information that becomes a competitive advantage that attracts international projects, global talents, positions Hong Kong as a construction excellence in Hong Kong, in Asia. So, but this window won't be, open forever. So, Hong Kong government responses, more than 25 initiatives across 9 organizations, systematically coordinated transformation. So instead of debating and government launch coordinated multiple departments offensive, not one initiative, 5 initiatives, 25 specific organizational initiatives across 9 government organizations. These aren't theoretical. There are planned for 2027. These initiatives are active right now from back to 2025, now 2026. Robotics in housing sites, AI safety systems and infrastructure, BIM mandates on capital works, education pipeline launches in secondary schools. This is execution. This is already deployment. And we've organized these initiatives into 3 strategic pillars. So this is how it sees. The Development Bureau is strategically leading this. They've been issued a BIM mandate. If you are building a government with government money on a project over 30 million, you must use BIM. But they've gone further. They're also pushing AI robots, not just for efficiency, but change how people perceive construction work. CIC, the Construction Industry Council, has established the Center of Future Construction. I think HKIBIM team actually visited the center. Physical hub, where young people and everyone can actually see the demonstrations, VR, AR, and the cave, which was there, and showing point of work BIM, case studies of major projects, and actual career paths, not abstracts, not theoretical. These are actually real. They created CIC AI awards with specific categories, AI adoption and AI R&D, sailing to the industry that AI isn't optional. It's a competitive battleground. And they launched AI master classes on January this year, January, specifically for workforce development, not theoretical training, practical hands-on AI skills. So that's what's actually happening on the first pillar. The second pillar, technical innovation. Building departments is developing automatic checking tools right now. Building code compliance is checking by humans, slowly, expensive, error-prone. BD is building AI systems that can run and read BIM models automatically, checking thousands of compliance points. They have 5 active automation programs running, not pilots, active programs, real projects. EMSD is building BIM AM, asset management system, for complex buildings. MEP coordination is a nightmare. EMSD is using BIM to create digital twins for buildings, then use AI to detect safety issues before they happen. Highways department is using AI for road defect detection, all the cracks, reading signs. Instead of sending inspections on site, they use computer visions to analyze pavements, identify problems before it becomes crucial. So this is the technical innovations where BD, EMSD, and Highways department is doing. Now, to the third pillar, operation and scale. Housing Authority isn't just using BIM, they're operating an industrial scale. 24 active robotic construction projects, not pilots, active projects. They're testing over 10 different robot types. They've established robotic hub where construction professionals can learn robotic operations and maintenance. The WSD is also using AI to optimize complex water infrastructure. Lands Department is building the government's BIM data repository, a centralized system where all the BIM initiatives connect and learn from each other. This isn't a scattered initiative. This is coordinated ecosystem. Every piece reinforces others. BIM mandates drive adoption. Robotic demonstrates attract talents. Education pipeline builds capacity. Policy creates certainty and systematic. This is actually what's happening in Hong Kong on the construction part. So look into these strategic pillars. Development Bureau maintains it's just a requirement, but it's a market signal. When government says BIM is mandatory for projects over 30 million, what they're really saying, it's like we're betting our money on our reputation, on credibility on this approach. The integrated Capital Works platform is equally important. Imagine this. Every government Capital Works projects, housings, road, hospitals, university, has its own BIM model flowing into a critical system. That system creates transparency. It allows real-time coordination across projects. It generates analysis about what's working, what's not. It creates a learning system at a portfolio level. And when government signals moving toward AI robots, they're not just improving efficiency, they're changing the visual perception of construction. Young person walking past construction site that has robots, they think differently about industry. They think technology instead of manual labor. Now, CIC, Construction Industry Converge, has a Center of Future Construction, which opened, May last year. It's a brilliant from a perception perspective. This isn't training a computer, it's a lecture. This is a physical space where young people can walk and see robots actually work. VR environments showing point of work BIM. Real case studies from completed projects, actual career path with salary transparency in industry professionals available to mentors. Why does this matter? Because young people career decisions are emotional and rational. The emotional component does this look cool? I mean, does it look cool? No, right? It has to be actually seen. So these are actually what's happening. So, and there is an AI masterclass launching on this month, 2026. This is a tactical workforce development. Not waiting for universities to update their curriculum, not waiting for training providers to create courses. The industry is taking action now. Here's what we need to know about AI. Here's how to apply to construction. Here's how to apply to real projects. The pillar creates strategic frameworks to market intensive. So we talked about building department, CIC, and then let's look into the electrical and medical system department, the EMSD. For complex buildings, MEP systems are coordinated, very, very painful. Everyone who actually worked in MEP will understand. Hundreds of pipes, ducts, cables, and all completing in a very, small space. Traditional coordination happens during design. You use clash detection to find conflicts, but some conflicts, you don't find it until you're actually on site. They have to work on it. And then delays, and then cost overruns. And EMSD is using BIM actually a bit different. They're creating digital twin of buildings, complete 3D models from all mechanical, electrical, plumbing systems. They're adding sensors, IoT sensors, that measure accurate performance. Now the system can monitor real time. Elevator performance degrades. The system alerts maintenance before it fails. Water usage pattern change. System investigates. HVAC adoption drops. Efficiency drops. The system diagnosis. This is just maintaining efficiency. This is preventive operation. You predict problems before they become crisis. And they host an international AI competition with over 200 teams from 26 countries. This is a smart position. Hong Kong becomes the venue where the world's best AI plus construction talent showcase innovations. Our city becomes the center of gravity of technology. So this is the move of EMSD. Now, High Roads Department. Roads are invincible assets until they actually fail. The pothole isn't just inconveniencing. It damages vehicles, causes accident, causes money to fix. Highways Department is using AI to prevent road maintenance. They've digitalized 440 standards details into BIM objects when designing a road intersection or drainage system. Designers work with verified standard compliance components. That's scalable, consistent infrastructure design. But more importantly, road defect detection. Camera-mounted vehicles. Those vehicles drive through Hong Kong roads continuously. Laser scan, point clouded, cameras across surface coordinations. AI model analyze the footage. When it cracks appear, even millimeter crack, the system flags it up, automatically generates a work order, maintains team to dispatch before the crack becomes a pith hole. This is pavement maintenance at scale. The cost of fixing a millimeter crack is far lower than fixing a pith hole. Safety improves because fewer holes means fewer accidents. The technical innovation pillar turns policy into operational reality. So this is the technical pillar. And the third pillar is the scale. Housing Authority, industry scale implementation. Housing Authority manages over around 2,300 over public housing blocks. This is massive coordination complexity. They're not just piloting BIM, they're deploying BIM across their entire portfolio. And they're testing robotic at scales, 24 active robot construction projects, not pilots. They're testing over 10 different robot types, spray applied fireproofing robots, concrete leveling robots, bricklayerings, facade cleaning, concrete demolition robots. So why so many different robots? Because the task has different requirements. A fireproofing robot solves a different problem than a bricklayering robot. Housing Authority is exploring a full spectrum. They've deployed a single dashboard showing all the projects, all material, all risk. Project managers can see Project A is ahead of schedule. Project C is running short of workers. Project B has material delivery arrives on Friday. They can relocate resources in real time. The AI discrepancy detect systems is elegant. Instead of inspectors walking through a completed building, comparing what was built against the design, an AI system does. But actually now, AI system does it. Automatically, it spots that human inspection might miss and forget. Quality improves while inspection costs drop. This is the power of AI. By 2026, Housing Authority will have over 30 robot assistant projects that move from testing robots to robots that standard practice. This is a construction industry future, and it happens now in Hong Kong. And the upper pillar, which is the Water Service Department, is using AI to make sure it never fails. They've built what's called STTSS, Integrated BIM Model of Physical System, GIS data showing system location, AI optimization algorithm, and IoT sensors on critical equipments. Here's a concrete example. Some system monitor 50 pumps. Each pump has sensors. Those sensors transmit data every minute. The AI learns normal patterns. Pump a typical run at 85% efficiency at 2 a.m. on Thursday because demands are low. One morning, pump A runs at 62% efficiency. System knows something is wrong. Before pump A fails, maintenance is dispatched proactively. So these are the core of AI, what we're actually using. The energy savings are significant. When you optimize pump schedule across hundreds of pumps, you reduce energy consumption by substantial percentage. Over the years, that's millions of dollars and thousands of tons of carbon reduction. Lands Department is an infrastructure backbone. Without them, all the other initiatives stays in silos, separate, incompatible. So they're building the government BIM data repository, a centered data hub with harmonized standards. Suddenly everything connects. Road projects can access with BIM objects from past similar projects. Emergency response team can visualize all underground infrastructure during crisis. Assets managers can cross-reference building systems with utilities. Planners can model city growth scenarios using real BIM data. It's not exciting. It's not cutting edge, but it's crucial. Without it, everything operates is isolated. The operation pillar takes technical breakthroughs and applies them at scale across Hong Kong infrastructure. So it actually combines everything together. Where construction, we traditionally work in different different disciplines. We don't actually talk to each other. So there's always a misunderstanding when we're doing construction. But when we put together with all these IoT sensors, all these informations, and what building lands department is doing is combining all this information and talks to each other so everyone knows what's happening. So let's zoom back a little bit and see these things. So Development Bureau Initiative, we have 9 government organizations, over 25 initiative contacts. Development Bureau mandates BIM on January 2025. Integrated Capital Works with AI robots mandates at 2026. CIC opens a Center of Future Construction at May 2025. There's a safety chatbot that can run, 24 hours. And there's an upcoming AI award. Timeline progress from last year to this year. Key impacts and metrics of each year initiatives. So this is a streamline how we are actually moving on. And we also have HKIBIM actually proving all this intellectual information together. And HKIBIM is not actually working only in Hong Kong, but it's actually further expanding to the Asian market. So policy levels. So if we go through everything, I think we covered everything from here. The construction transformation from fragment silos to coordinated linked digitalized systems. So building department has automated code compliance. EMST has their building a BIM assessment management system. Highways department has the road defect detecting system. Water supplies department has a smart water system. Lands department actually gathers all this information and links it up together. Now we have a full coverage of digital twin in our Hong Kong construction industry. And these are not just theoretical. They're actually in pillars and they are working out together, and we're doing it one by one at the stage. So now if we look out what we're actually doing, these actually all interlink, and this is actually going further as a digital twin initiative, which Singapore actually did it with only one platform, but we are doing it with multiple platforms with AI and IoT sensors together. Now, so we all have this kind of information together, what the government is doing and how it needs to be done. Now, but how can this be actually operative, and how can it be actually constructed while if it's only operated in front of the table? So now I want to actually talk about something very fundamental about BIM implementation tiers. Most people only think about a BIM. First part is about the design phase, our coordinations. Let's use BIM to find clashes before its construction. That's the dominant image of BIM actually everywhere. Who doesn't actually know about construction, whoever heard about BIM will think about it's about design. So most likely, I will put this as a design phase as tier 1. Users are more likely architects, engineers, uses it for clash detection, design coordination, which is around 70% of global adoption. Key benefits is preventing expensive rework by finding conflicts during design. Well, time investment is actually minimal. Most architects will not allow clash when they have seen it, right? So will help to reduce design errors. Tier number 2 is about project management. It's in the planning stage. Project managers, planners use 4D schedules, logistic plans, resource management, which is around 30 to 40% of global adoption. Key benefits are optimized construction sequence, identify bottlenecks, planning, logistics. Adoption challenge is required discipline, training, and time investment, which means you need to know construction sequencings and construction sequencings at time. Tier 3 is a daily supervision. It's actually, supervisors actually who senior manager levels and actually who works for them. Daily work scope, real-time coordination, daily planning, which we actually use every day with novice work, like reviewing the model or where there are actual clashes or where we wanted to review before the construction works. So we do it in the office, not on site. Currently, global adoption is around 20 to 30%, 10%. Key benefit is reducing daily conflicts, keep workers on track, adopt challenges, or require technical infrastructure training. You need to train your workers to let them understand how to use Novice Work Freedom or any viewer program. So, and then, some people won't be so friendly with learning a new software. So that's another part of a challenge. Now, the fourth point, which I actually think is the most important part, is the frontline workers who actually goes on site, and technicals who operates task-specific 3D context, who actually looks into the tolerance, who actually uses, who actually does the concrete pouring and stops it and re-pours it because of the concrete truck, pouring truck was stopped, or because they have to pour somewhere else for the urgency and then they have to restart it again. These are actually, if these people have the BIM model and how to use it, they will have more ideas how to prevent tolerance issues, sequencings, or hazard, very dangerous issues. Currently, globally, I don't see much of it, maybe around 5%. And this actually really helps for the workers' empowerment, informed decisions, adopt challenges, require simplified BIM, but it actually really needs to, simplify the BIM model. But you don't need the whole system together. Like if you're actually just pouring concrete, just show the concrete model. If you're just doing installation of the MEP, you gray out the concrete structure and emphasize the MEP dock works. So these actually need some training to the workers as well, but it really needs a significant cultural change. Now, here's what's crucial. The UK achieved 70% of what I see in design adoption, which is tier 1. Singapore achieved 80%. Both countries are advanced, sophisticated market, but both are stuck in tier 1 and 2. The barrier to 2, 3, and 4 isn't technology. It's about, do we have all this access? Cloud systems, internet. The barriers are organizational. How do you simplify BIM for field workers? How do you train them? How do you build the culture? So this is the part where I think that we can actually have a chance to grow our workers in a higher level to make more intelligent and actually bring all the intelligence together on the know-how and lesson learned parts. We can implement tier 1 and 4 simultaneously because they know what all the walk around methods of when construction issues happen, If we implement that into the design stage, we'll have more information and more way forward when issues happen. We can skip from most advanced design BIM directly to the most advanced worker level BIM that will give Hong Kong a very competitive advantage over the global construction market. So I think that's where I think what we can do. So, but before we go into all these technical and all these information parts, I think we still need to go go through the conversation for something very fundamental. A quote from actually 𝗥𝗲𝗍𝗆, who was basically invented BIM in the 1970s. He's called the father of BIM. And his quote was, "The computer is a tool for professions to think better, not think for them." This is actually very important. BIM isn't about replacing human judgment. It's about augmenting human judgment. It's about giving professionals and the worker levels about better information so they can think more clearly. 𝗥𝗲𝗍𝗆 has this thoughts in 1975, which is around 50 years from before. These were technical barriers preventing us from realizing his complete version. Computers were at that time expensive. iPad, tablets, they didn't exist. Cloud infrastructure was really unthinkable. Internet connectivity was very spotty. We used telephone lines at that time. Field workers couldn't even actually think about BIM or think about a 3D model. But those barriers all have been removed. Now it's 2026. We have tablets. We have commonly technologies. We have cloud reliable 99% uptime. We have 4G, 5G connectivity, ubiquitous. Mobile apps can display complex 3D models at real time. The technical barrier is gone, actually. So now we can realize Eastman's completed version. We can bring BIM to the worker. We can augment the worker's thinking. We can give them better information so they make better decisions. This is the fundamental insight driving everything we're discussing. Tier 4 BIM is checked in its 50-year-old version finally comes to life. And what actually happened before is Hong Kong actually really did it before. I mean, let me bring up some previous projects that what Hong Kong and South Korea and has actually done with BIM. This project is designed from 2004 and completed in 2008. The owner is Swire Properties. Gary Technologies actually built this BIM model. At that time, the owner actually had the vision of new technologies and it wanted to be actually even at that time, at 2008, at 2007, he wanted as a digital twin that they can actually open up and see what it can be, see the MEP systems, how it's moving and where the equipments are. So I remember that there was a pilot part that we can check and all those properties were actually there. This building was actually built by Gammon and it's a 70-story building. And it moved and removed 2,000 design clashes. And in an official document, it shows 24 months ahead, which means 2 years, and 20% of cost saving by implementing BIM. This is One Island East. You can see it from the Hong Kong Island. So this actually was implementing Tier 1 to Tier 3 BIM at that time. So another project that actually Hong Kong technical team actually deployed. This is the Dongdaemun Design Park project, which was designed by Zaha Hadid. There are more than 445,000 unique aluminum panels, which is 86,540 74 square meter complex geometry. These unique panels are all different. They have all unique shape. They have single one-way curve, two-way curve, and flat panel. And it was a very big challenge to manufacture with a short time of schedule. So there was new technology developed based on the designer's program. And it actually reduced a lot of cost saving to build this one. And for the panel itself, there was a machine actually created from a joint venture called Steel Flower, Steel INC, and Steel Life. These three companies actually made a joint venture to actually invent the multi-point stretching forming technology. And I'm pretty sure that whoever has interest in DBP project has read about that paper and how this technology actually exists. And this project actually was using not Revit. It was using a CATIA-based program called Digital Project, which was invented by Frank Gehry, who actually passed away a few months ago. And not only about the aluminum panel, the challenging was actually the exposed concrete. As you can see, this is a sports memorandum project, which is this part. It's a freeform shape that has to be casted and to have this kind of shape. So what we did, this is one of my projects that I participated. We made the rib here to form the geometry of the shape and cut it out with 300 millimeter distance. Actually, Kevin Wan actually developed the script to do this, and we all worked together on this one. So the workers actually placed all the formworks like this to maintain the shape. But the problem is the workers were saying this is a bit risky because the shape will not be always the same because of the material. The concrete has its own specialized material thing. So what actually happened after we removed all the formwork, it was all bumpy. So they had to grind it. So actually additional cost has to go inside while people were still removing it. So we had this kind of lesson learned. We should have actually learned heard about it from the workers. So what the worker actually told us is, if they have a pattern or if we have to maintain it, why don't we use the same technology that was used on the aluminum panel? Why don't we panelize the formwork? So we did it. So first, there was another exposed concrete area that has to be built. So it was panelized as 1.2, 2.1 size, and also the drill hole as exposed concrete area. So we generated all these kind of things, shop drawings, which is currently a very normal practice at this time. This project was back in 2009, for your reference. And then we did the work the same way. And then the result was fantastic. So if the workers had the access to the BIM model before it was constructed, we won't have to go through this pain. If these informations were handed over to them, so we can have more better decision making before things happen. So this is what Tier 4 BIM actually comes from. If we give these informations, the design, the information that actually controls the quality, that actually will bring impact to the time and to the project, it will actually improve a lot. So lessons learned. Okay, then let's give all the full informations to the workers on site. So the next project is also a project which was built in Korea. This is a Louis Vuitton mansion project, which was designed by Frank Gehry. It had two-way curved glass panels, which is around 965 square meter, a 6 meter tall zigzag glass. And to make this possible, the steel structure that holds the glass shouldn't have any tolerance. That was the construction specification. So it needs to be created. The manufacturing had zero tolerance. So to do that, we actually asked the workers how can we do this, and what is the best way to do it? So we did a very specific 3D scanning. They directly gave the information how they wanted to do it. So there was a laptop, and there was also a guy who was very good with Rhino and digital projects. So we worked together as a team and communicated, seamless with the model, exchanging emails, putting all these BIM informations with the workers together. We sat down, we worked together on site, we worked together in office, and find solutions to it. So as you can see, we just worked on the computer with them, the model itself, but removing unnecessary parts, simplified it. So if you can see in the picture, there's only the steel tube, which is these areas here. And then, finding the ways, the best way how to achieve it. So even for these workers who actually, building on site, use the BIM model to find their best position and how to do it. So this was a successful case, and most likely people will know that most likely Frank Gehry projects has leaking issues, but this project has no leaking at all, no defects. So I'm very proud to say that giving the BIM information to the next, the worker who has all these kind of intelligence actually really works. And this is where we can actually, push forward and to do so. So connecting the dots, White Island East, we implemented tier 1 to tier 3 partially in the BIM, demonstrated the BIM phase clash detection prevented thousands of clashes, saves millions of dollars, 24 months ahead schedule. That's already a big saving. But the scope actually was, limited. Who actually drove the BIM part was the designers and the coordinators. But for DDP project, BIM was actually used for manufacturing, sequencing, and then installation. Of course, the designer, which was Eddie Ken, was putting his all roles inside here. But the main achievement was actually achieving all these kind of geometrical shape by actually communicating with the site workers and the designers together simultaneously, But it wasn't actually the workers who actually put their effort. We actually asked them, and then it's a little bit not aggressive enough to say so. But for the Elizabeth Pond project, it was a full tier integration, which the workers actually proposed new ways how to fix this and actually drove the project for success. And this doesn't just come with actually, telling them what to do. They actually know how to use these information when they get respect from what kind of information they receive. It's not just paper drawings. It's the whole aspect of what they're going to build and how it's going to be built and how they want to be, because everyone wants to be, perfectly recognized when they're doing their job. If you give them, relevant information and respect, they will bring up all their skill sets. So tier 4 BIM was actually success in this project. They brought everything that they know. So quality impacts from all these kind of projects from now. Mechanism, clash detections, rework demolitions will reduce cost. 4-tier BIM will also prevent clashes, but also improve the rework. And mechanism 2, precision tolerance control. If we give them all these kind of information, defect reduction will go very, very low. But this is all the perception that if they bring all these informations, if the workers have, dedicated their full interest on the project to do so. And third part is the sequence clarity. If we know what's coming first and what's coming next, they won't be confused. What we actually face on the construction site is what comes first, installs first, and leave. But if we actually manage this, but bringing them the respect of showing them what we're going to do today, will change these kind of attitudes by showing them what has to be done and which team actually has to be done, has to do. These actually can be hold up in a early morning meeting, but I'm most likely in morning meetings and construction site they have this called toolbox meeting. They do the morning exercise. They do like a safety acknowledgement, and then they separate by disciplines what they have to do. At that time, if we can show these parts that what we're going to build for each trade at a specific location, you go first, A team goes first, and then B, then C. While A and B doing, C team does different location of work. These sequence, if showing, it will actually will transform the construction industry to a better place. And these are the core technologies that we actually have to bring into. So, and also Hong Kong actually announced a smart site safety system, but this actually aligns with the Tier 4 team-specific hazard awareness. This is an example. Today, you're installing ductwork at level 15. Watch for exposed rebars at north end. Look out for the fall protection at west side. Hot work restrictions until 6 p.m. So if you show this not by words, not by just verbal, but in the 3D model perception, it's very, very, precise. You can do this. So, and these can, the safety issues can be actually minimized by showing all these information. So, and the government actually built around it the Development Technical Circular Awards number 3 in 2023 as mandatory for projects over 30 million Hong Kong dollars, must have smart devices, AI cameras, smart helmets, wristbands, IoT sensors for hazard detection, real-time alerts, mobile plants alert system, tower crane alert systems, and centralized data perform integrated safety and personal progress equipments. 4S plus BIM integration, digital twin enables simulations for high-risk activities. So these are actually all monitored with AI. So again, to summarize what I was showing today, 7 subjects attract young people to construction. Technology first, clear progression, professional status, skill transfer, intellectual challenge. Money is the thing that I actually cannot say so much, and work-life balance. This actually brings construction, BIM comes to genius attractive to young people and smart people, and who actually doesn't know where there are new opportunities that can bring. So the career progression shows from roles to responsibilities. We have BIM technicians, junior coordinators, BIM coordinators, senior managers, directors, and VPs. These are actually responsible levels that can actually grow. And this is not just BIM team, it's actually within all the disciplines. So, but there is a learning curve for youngsters who actually learn how to understand 3D. But if you are actually learning construction work from 2D paper, it's quite obvious. Because you have to imagine how it needs. But if you use 3D visualization tools, it's much easier to complete it. So there's a learning curve that for youngsters to look into the 3D models. So what HKIBIM actually did for the secondary school students was actually a big push forward. So these are some of the fundamental suggestions that how secondary school programs and what we currently have at this moment. So for a special after class grades for grade 10 to 12, they can have these kind of basic trainings in BIM softwares and modeling softwares. From grade 10, they can actually understand what are the CAD basics, BIM softwares, and 4S safety system and the 4S initiatives. By grade 11, you can start doing some of the modeling, which HKIBM actually did. And grade 12, you can do some smart construction technology, and you can find some mentorship and build ways of thinking how the construction actually moves. And currently, what we do have is CCBC, membership of HKIBIM, and CCBM as well. So these actually have some pathways to be a specialized technical integrated construction member. So HKIBM commits leadership, and this is one of the commitments that HKIBM actually initiative pushes through. Strategic curriculum adoption, standardized education training. We did the automation arena starting from this last year. I think it was 2 years straight, right? On 2023 and then 2025 for automation arena. And all these initiatives actually bundle up together to train all the construction members and the youngsters to attract to this market. But there are also challenges, but worker adoption resistance, we need to actually break through this. There are education capacity bottleneck, and there are also cost implicants. Insufficient market demands. Some have, some are not. Like what I shared about Tier 4 BIM is most likely to convince the worker levels and the skill for people to use more technology to bring out their information to improve the construction the projects. Stakeholder alignment issues. They have every stakeholder has their own phase of development. They have their own milestone. They have their own leadership together too. And technology reliability also concerns. We need actually testing before actually deports to on-site. So there are also testing parts that has to be gone through in multiple levels before it goes on-site. But Hong Kong government is actually doing all this at the same time. So the conclusion, we actually gone through all of this in 3 pillars. And I'm pretty sure that everyone understands what I'm trying to face here. Finally, 4 commitments that will make the transformation for real. So LOD specification actually has to also grow because when we look into construction models, not only about clash detections, but if the workers are using it, they need more details to actually produce, to project. So we do have Hong Kong's competitive positions that is ongoing, and actually improving. So technical barriers has been removed. Policy quality is very strong, but we still have some critical issues with resources. But with all these kind of information tied up together, we can actually leap up with the current situation of the market. So, and this is one of the ideas that what LOD can actually improve in. So we have to actually have an enhanced LODG for worker level for construction use. Currently, most of the BIM models, what we so-called, still are a bit simplified. They're not fully modeled in everything. Like couplers, these are not actually modeled. Water stoppers are not modeled between concrete joints. We do have concrete sleets, but we don't have water stoppers when there are things that actually needed when it comes from. So we need some of these LOD definitions to be a bit considered what work that really works on site. Rebar couplers, ducting and piping couplers, water stops between concretes. These are just some of the examples that are not actually inside our LOD 400 status. And since the time is up, I actually rushed through the few last pages. Thank you for your time for joining us, joining today. And I will give my part to Juan.
All right. Thank you, Jae-woon. Thank you, Jay, for your presentations. So we are now in the Q&A sessions. So members or non-members, so please feel free to type your questions in the Q&A. Maybe I'll start first.
Sure.
Right. You mentioned about from tier 1 to tier 4 in your PowerPoints of being implementation. So for these classifications, do you want to share some insights how you classified this and how you define this?
So actually it's a classification of user and actual worker user levels, how it has in places. So for tier 1, let me go. These are actually focused on one moment to share my screen. Okay, so it's about focusing on who actually uses it and what is the main purpose for using it. It's actually for design coordination. Even for construction, we need construction design. So tier 1 actually focus on design parts before it's deployed on the construction site or deployed before shop drawing is generated. Tier 2 is about using a frozen BIM model to use for planning and sequencing. So these are actually optimizing the construction workflows and the disciplines. At tier 3 is about an overall daily work scope for the people who's on site, who actually sees it, who sees the working area before they go on site to do it. But tier 4 is about giving the BIM model to the worker himself and let the worker to make all their own judgment calls to do their actual job. So it needs to be very specific. They need to have some technical skills behind it. They need to know how to hide some of the objects. They need to know a little bit of the tree structure. But we do have novice work and all these kind of automation skills to actually hide those unnecessary information and give it to them, and they will actually work do their review it and see what has to they can do. Actually, this is a bit more reality for software based. We can say sight vision plus using these kind of information. Sight vision has a tool to transparently make the model transparent and overlap the site conditions and make the judgment calls. And because the BIM model is a perfect as designed or as constructed condition, which is quite different from the site. So the workers will judge, since this wall and this wall is disconnected, what kind of works that has to be carried out before. And these are the judgment calls that they can actually imagine. This is the tier 4 point of work that I was trying to explain.
Okay, just for clarity, right? This is for these tier definitions. So this is that you came out with, and it's more focused on users.
Yes,
right?
user basis.
Yeah, actually for users. So for example, like during the design stage, clash detections, coordinations, these are very much well recognized and well easily achieved KPIs in terms of BIM utilizations. So these are the key benefits and what we have achieved to date, right?
Yes.
Okay. You also let me see. You also mentioned, okay, you get advice, right? So you spend 18 years, right?
Yeah.
You will consider the fortunate batch, right? You're right on the way. You develop your career for the last 18 years for BIM implementations. So yeah, I think what you are trying to convey, you have actually enjoyed your career for the last 18 years, right?
Yeah.
You were not the traditional architects. You were not the traditional engineers working in the design consulting firms, right?
Yes.
You have exposure in contractors. You have been working in different regions like Singapore, Hong Kong, Korea, right? What kind of advice will you give us, the BIMers, right? If you are going to make some changes to the BIM industries, what do you think the Hong Kong local industries can improve on? Really, one key critical aspect that you can keep a recommendation so that we can improve or make changes on.
Honestly, I think Hong Kong's industry is quite advancing in pillars, but as I said before, when I was quite actually amazed by preparing this slide for this deck today, and the lands department, which actually is doing is the actually gap between most likely in construction industries. It's sewing all these informations to be used in one platform, and this actually for individuals, because everyone has their own thoughts, it's very hard to say, but the best successful persons that I've seen from the construction industries are who are very humble at their position and trying to understand everyone's their partner worker. They actually work of course for their daily tasks, but also considers the one who actually sits beside you, and they care each other of their work and how to make progress with the project. The fundamental part, what I see is the people who actually try to understand the project, the reason of the project, why it needs to exist, and who's going to be the end user, brings the best quality of their work and also the best respect to the workers, that goes to the project. So these are the things that I have seen. In the Hong Kong industry, I think there are so many specialized people, but they're most likely there are quite a lot of people that they hide their technology inside them. So it's the leadership on the top management, how they can, expose those technologies and combine it together and make it something more new. They know they have these kind of technology, but they don't know when it needs to be shown, when it needs to be adopted. So I think some of these need some encouragement to individuals and also recognitions, but also giving opportunities with showing them all these kind of respect to them. And respect actually is not just talking. It's about providing them with rich information, which I think the BIM model itself is the core portion of it. So that's where I'm coming from.
Okay, I think I take it from I'll just summarize what you just conveyed, right? I think the people really needs to work on the BIM models. People really needs to look into the BIM models. Similar like the traditional practices that we pick out 2D drawings to review it, right? People needs to collaborate more in terms of sharing technologies. Of course, there's different aspects, right? There's IP issues.
Yes.
There's IP issues between different parties. So I guess, but I think as a BIMer, right, you see that there's always upgrade on software. There's upgrades on plugins. There's upgrades on the scripts, right? So and things changes very, very fast. I think technologies like AI is evolving very, very fast. Hardwares in terms of technologies, hardwares, softwares, and programming and automations. These are really moving very fast. And to date, for BIMers like us in Hong Kong, I think we are exposed to what you mentioned, 4S. Not only, so we're not only well versed in technologies and softwares. We are also expected to start learning technology on safety parts, right? Like 4S, right? And so we're also looking for expertise or crossovers in automations, programming, someone who knows construction industry, someone who knows a little bit of design, someone who knows a little bit of constructions. So it's a crossover of multi-trades. And of course, sometimes I questions does these people actually exist, right? Okay, let me see if there's any questions from the Q&A. Okay, for members, if there's any question, please type in the Q&A. We'll just give you a couple of minutes more. If not, we'll just end the session. Sure. SS, right? So what do you think as a BIMer, and how could we evolve? I think there's many ways we can evolve, and the BIMers can really evolve into multiple different sub-disciplines.
True.
Right? True. If you are interested in automations, you could really look into this, right?
Yes. Most likely, when you work in the construction industry, they actually you go into one part of the discipline and be the specialist on it and go deep inside. But for BIMers, it's like widely approaching everything. You need to know most of every discipline's workflow, and also discipline's major parts. So for the BIMers, I think they need to choose a path between two parts. One is technical wise, or management wise. Management wise needs more of understanding on different disciplines, special conditions, concreting, steel structure, facade, what if you're doing all this, you need to understand also weather type names and also waterproofing informations too. But if you're going into technical wise, you need to know how to do coding, at least minimum, and you need to know how computer science, and you need to know how machines. You need to understand machine languages, like not only about IFC, but how IFC actually started was STP step. And all these language parts should there. So these are the two main roadmaps that I think that the BIMer can choose. One is going to a management path road, going into construction discipline pillars, but also integrating all these informations to automation parts, but not specialized on coding or AI, but all these trade information to be linked and sewed together. Another part is technical wise, modeling methodology, and technical avoidance of errors that you can actually resolve. Software versions, what kind of tools they have inside, and what are the limits of the tools that they have, and what language can do automations in a better way. What language can what software can do better rendering to do it. It's simply saying that so ReCap has a better function of overlaying 2D drawings to the 3D model in a section cut, rather than using Navisworks plus their overlapping tools. So I think there are major in big pillars, it's technical and management, and then deep down, you need to actually integrate all these things together, because the BIM part actually is not just about one source. It's multi-trading and combining everything and unifying as a one thing.
Okay. All right. This we'll just do one Q&A session from the member. So this one member, 𝗥𝗲𝗹𝘆. So this is a hard one. So at the recent CES in the United States, it was indicated that 2026 will see a strong focus on the development of physical AI, particularly on robotics. How do you think this trend will impact the future of BIM in Hong Kong? Do you think that what would be the role of Hong Kong BIMers play in this case? Just FYI, I just took a few seconds to Google CES. So CES is actually an annual trade show organized by the Consumer Technology Association.
Right.
So it was just last held in January 6th in Nevada, Las Vegas.
So I think the part is development of physical AI. Currently, everything in AI right now is most likely software. We use the information to do something. Physical AI is actually a robotic part, which can to ask the robots to do something for you. So I think Hong Kong actually has this part integrated into the development pillars. I think I actually presented at the Housing Authority and Housing Authority and Highways Department. Highways Department actually uses all these kind of drones and automated automobiles that catches up all these cracks, all the namings with AI, and actually signals it back to the people who needs to repair. Housing Authority is actually testing all these kind of demolition, fireproofing, and concrete layering, and skirting. All this is actually powered by AI plus robotics. So I think it's already happening in our industry. And for us is actually how it's how the BIMer to do is understanding the project well enough and see if there are any pillars technically. If we go inside the technical part, we have to look into the programming part, and then understanding how the sequence has to be done to to program things, we need to know the sequence before we do program. So, and that's the part. So if we are an existing personnel, which at our age, we need to know programming because we already know the construction sequence. But for the younger generations, they actually need to learn the construction sequence before and the coding at the same time. But they will find a unique area which we haven't actually found out that can be an easier part to find efficiency to bring things in an easier way. So I think this is where I hope this could answer his question.
Okay, sure. Yeah. Okay. All right, it's 5 p.m. now. So we'll end. Thank you very much, Jay, for your time for preparing this deck. Thank you for your time to present it to all the audience attending this webinar. So we'll hope to see you again in the near future. And so all attendees will end these sessions for today. Thank you for your participation.
Thank you for your time and thank you for listening.
Yeah.
Thank you very much.
All right. Bye now.